Folks, welcome. Welcome to the live stream. Thank you so much for joining us. If you're grabbing a snack or whatever you got to do, you got some time. I'm going to rabble on a little bit before this thing starts off. Apologies right up front. I started a print on my Bamboo Labs X1, which is right here, like midway through the day. I didn't realize it's bleeding into the live stream. If it's too loud, just let me know. I'm doing my best. I closed everything off. Ooh, I can hear myself. And I have my KLP1 on right now, so it's not doing anything. It's power though, so you might hear some fans. I apologize about that. Well, thank you all for starting out or coming to the Klipper introductory live stream. If you know Klipper, like some of you do, I see Yard Mullet, awesome name. You're familiar with Klipper. I'm hoping this might open your eyes a little more to certain aspects of Klipper, but I'm really going to try and narrow the approach down here to people who know absolutely nothing about Klipper, just complete newbies who are afraid, like Misumi, of code, as we think Klipper ran on all this code, and I guarantee you're going to see it's like all copy and pasting. Someone like me couldn't be doing this, I promise you. Okay, I'm not muted myself. I've done that before. I think we're kind of ready to go. Okay, good. If you don't hear any of them, that's great. I can hear the X1, but I closed it up, and the KLP1 is just really the fans. All right, Colin, great to have you. This is the Klipper live stream. So, next to me you see the Ender 3 V3 SE, mouthful. This was provided to me very kindly by geekbuying.com about a month ago. We did an unboxing on this. This comes with Marlin firmware. Great printer right out of the box. Has a bed probe that creates a mesh for us, and it also has automatic Z offset adjust. Another great component that newer users, newer 3D printers don't always learn about, don't always hear about. This does everything for you. So out of the box, this is a great printer. However, we can make it better. We can put Klipper onto this. This is a stock STM32 chip. This can take Marlin, which it has out of the box, and then we can put Klipper on this. And today, that's what we will be doing, putting Klipper on this 3D printer. So first, I actually have some notes I might be going to here and there because I want to try and keep this streamlined. What is Klipper? What is Marlin? How do they differ? Well, they're both firmwares, obviously. A real shortcut way of thinking of what firmware is would be like an operating system. Let me hit you with a different angle here. Would be like an operating system. If there's some lag between my voice and my mouth movements, I apologize. I can see it here. I don't know why it's doing that. So you can think of firmware as an operating system. You have Windows on some computers. You have Mac OS on Apple products, and they generally do the same thing. You can surf the web. You can do all these things. You open PDFs, record audio and such, but they do them in slightly different ways. Apple's better at certain things, audio-visual. Macs have some more freedom, I guess, if you want to call it that. So they do the same thing, just operate in different ways, and that's kind of similar to Klipper and Marlin. They're both going to let our 3D printer print. It's going to heat up. It's going to extrude filament. We're able to make a bed probe, watch it on a camera. We can all do the same things, but Klipper is designed to operate different than Marlin. And one of the biggest advantages of Klipper is it works in a very physics-based, kinematic-based way, meaning Klipper doesn't care what kind of 3D printer we have. It has its own physics that it code that it reads and operates our printer with, whereas Marlin really needs to know what kind of 3D printer we're using because when we compile firmware, it needs to know all that information. It's a mouthful, don't worry, you're not going to have to, it's not going to be on the test, don't worry. Tea, by the way. A little bit of tea, throat's always killing me. It's like winter, why not? Okay, so with Marlin. This is a main board. This is a BTT Big Tree Tech SKR Mini E3 V2. So in the bottom are our 3D printers. And this one, it will be right here. We opened it up a few weeks ago. This is the main board that will be sitting right here. It's different, obviously, on this, but this is just an example. Sitting right there. For Marlin, your firmware is flashed onto this main board, and this is what operates everything. The stepper drivers, the stepper drivers are here. The stepper motors are plugged into this. Our heaters are plugged into this. Our probe is plugged into this. This is the brains with Marlin firmware. Everything is on our main board. So when we flash Marlin firmware onto our 3D printer, we're flashing it onto this main board, and that is the brain. This is it right here. That's your printer. The brain is the main board, all on this main board, and all the operations of printing are conducted by this main board. There's a lot that goes on when we print, right? There's heaters that have to be heated up. They have to be calibrated. We use PID tuning, so it's constantly registering heating temperatures. It's reading G-code. It's parsing G-code. And of course, we know G-code is the lines of code that make up our print. It has to go through every line and perform different functions. Marlin has this main board doing absolutely everything. Okay, that's how it's been for centuries. That's how it's been forever. This is a 32-bit board. It's very capable of doing all that stuff. Klipper looks at it a slightly different way. Klipper says the main board's great, right? This can perform a lot of good functions. I mean, it's got stepper drivers in here. It's going to move all this stuff. But what if we used a better computer? This is a Raspberry Pi 4, I believe. This is basically a computer in my hand. This is just like the computer sitting right next to me. It's just a single board, small computer. Klipper's saying, what if we took the brains that are operating this main board and we put it on a really fast computer? That's really all Klipper's doing. So Klipper puts the firmware right here, right in this computer. It can be a Raspberry Pi, it can be an Innovato Quadro, it can be a PC like this. Anything that can run Linux can operate Klipper. Putting it on there, not hard, we'll go over that in a little bit. So Klipper puts or makes this single board computer the brains of the operation. That doesn't mean we're not going to use our main board. The main board is still in our 3D printer. So what's the main board going to do now? It's just going to carry out operations. This brain, this Raspberry Pi or this Innovato Quadro that we're going to use to host Klipper is going to do all the computational work. It's going to do all the G-code parsing. It's going to maintain the heaters. It's going to look at upcoming G-code moves and make sure our printer is doing it. And it's just going to filter and tell our mainboard what to do. That means we have two years working our 3D printer. So we're going to be capable of a lot more movement, well, not more movement, that's a bad way of saying it, more accurate movements and more precise movements simply because we have just more utilities running it. Now that's the big definer between Klipper and Marlin, right? Marlin uses the mainboard, Klipper uses the mainboard as a tool, but it harnesses the power of a computer by using it as its brain. That's the kind of the idea. I hope we're on the same page with that. There's obviously a lot more nuance to it, but that's the general gist. This is like the stupid scenario that I thought today. I think I saw Jumanji recently. I don't know why. Picture a factory, a brick factory that's making shoes, right? You can only put 100 people in this factory. This is Marlin we're talking about. So this is a shoe factory, 100 people, big brick building. They're all working there to produce shoes. The first level is all the laborers, about 70 people. They're all making the shoes. They're pressing the leather, they're making the laces, they're doing all that stuff. But you need like an accounting department, you need human resources, you need finance, you need sales, you need a CEO. So those other 30 people that aren't making shoes are just doing other tasks. So now you kind of have your workforce spread out. That's Marlin. 100 people in this brick building making shoes, but they're all doing different jobs to get there. Marlin. Klipper. Klipper comes in, buys the building, says, you know what, we want to use your 100 workers, but no, you're not going to be finance anymore, you're going to be HR. Your 100 workers are only going to make shoes. The factory floor is completely flush with people. Klipper then makes an off-site building next to the shoe factory, and that's what handles all the finance, the HR, the sales, and it's really good at it because they have so many more people in this building. That's kind of how Klipper operates, if that makes any sense. It's better, that's all you need to know. I'm joking. It's not necessarily better. It depends on exactly how you want to work it. No, you should not be worried about running Klipper from a virtual machine. If you can run Linux on any of these computers, on any computer you use, Raspberry Pi, Quadro PC, you can run Klipper. If you're running it on a virtual machine, meaning you have a PC like this and you partition half of it to a virtual machine, or you're running your Klipper-based host device on a PC, you really usually want to make sure that it's dedicated to Klipper, because if it's running Klipper operations, if I'm running 3D printers using my PC and I'm doing other things, downloading videos or something like that, obviously bandwidth is a problem, and you could start interacting or could degrading your printers. You kind of want it to be just its own device, but Klipper can work with very, very minimal operating power, meaning you could get a PC or a laptop you have laying around from like 2010 or 2012. That's like a long time ago now, which is unfortunate. You could put Klipper onto that and it will still work wonderfully. Klipper does not need a lot of resources to work. That is its second advantage. This is like a TV box. This thing is, it costs about $30. It's called a TV box because sometimes that's how they are packaged, but this is specifically an Innovato Quadro. It has Linux already flashed on, so the operating system. It's got Bullseye, I think, on here. Doesn't really matter. All that matters is this comes equipped to run Klipper already. So the idea with this is, when we get one of these devices that's going to run Klipper, we need to put an operating system on here that Klipper can flash onto. Something Linux-based, of course. Raspberry Pis are unique to a Raspberry Pi. I have a VoxLab Aquila video that goes over how to put the operating system on this. It's very simple. We flash it onto this SD card. The SD card goes in the Raspberry Pi, and we power it on. It's really simple. It's all copy and pastable stuff. It's just kind of follow the dots or connect the dots. For the Innovato Quadro, we're ready to go. This has everything we need on it already. It's got some bloatware, if you want to call it that we kind of turn off when we first get it. We don't want the desktop mode to be working. We don't need it. This is going to be what's called a headless setup, which we'll get to in a second. So with the Innovato Quadro, we're basically ready to go out of the box. We have to give it some internet through Ethernet, and then we can start flashing Klipper onto it. So that is the difference between Marlin and Klipper. Marlin operates with the 3D printer and the main board as the complete brains. Klipper comes in and says, I want this really powerful computer to do all the computational, all the thinking work, and this main board is just going to carry out the tasks that I give it. This allows us a lot of legroom, more precision, and now we have a computer sitting next to our printer working on our printer. That means we have anything you can do on a computer, you can do on this. Wi-Fi controls. We have USB inputs. We have a ton of different options for us. That is one of the things that makes Klipper great. It's the options and the features that it provides us. So that's sort of the difference. Bad downsides to Klipper. You need to buy something obviously extra to run Klipper. Usually these are cheap. Raspberry Pis used to be cheap back in the day. Now they've gotten expensive since COVID. The Quadras, these little kind of TV boxes, have sprung up. They're about $30 to $40 now. They're relatively cheap. You can find a little PC in your house, hopefully. That will be free, I don't know, depending. You can find very inexpensive options to host Klipper on. So now I have my 3D printer. Get this faux main board out of here. I have my 3D printer. It's running Marlin firmware. It's great. I love it, but I want to upgrade. This is that printer. What do I need to do? Well, I need to do two things. I need to get a device, which we're going to call this, a single board PC that we can run Klipper on. And then I need to flash Klipper onto the main board. Those are two separate operations. The first one we're going to deal with is the host device, is what we're going to call it. So the brains of the operation, whatever we choose to run Klipper with, whether it be a Pi or a Quadra or a PC, that's called the host device. That's hosting all that computational power. So if you ever hear me say, oh, the Klipper host device, this is what I'm referring to. Whatever is running Klipper for your 3D printer. So we need to install Klipper onto the host device. And then once we do all that, we're going to flash Klipper onto our main board. And if you've ever flashed firmware onto your main board for Marlin, for instance, it's the same exact thing. We get a file, we generally put it on an SD card, we'll plug into the front, we power the printer on, and then the firmware gets uploaded and flashed. That's it. There's nothing different. And of course, we have Klipper on both of these machines, and we need to work them out, and that's what we're going to get into today. So we are going to start with, the slicer, the G-code stuff we're definitely going to get into. Probably a little later after we get into the flashing and the onboarding of Klipper onto our machines. But we'll definitely talk about it maybe briefly in this video. I don't know this is going to be step A to Z on everything we're going to get to flashing Klipper, but this is going to be a very large chunk of it. So I have my Marlin-based 3D printer. I ordered the Innovato Quadra. This is what we're going to use today as a host device. I ordered this Innovato Quadra. What do I do? Well, the first thing I need to do, I'm not going to flash this today. Just spoiler alert. Just because it takes some time downloading some of the files, and I kind of wanted to keep this brisk. I have my Innovato Quadra. It showed up to my house in our scenario. What do I do? Well, I need to give this internet. I have a whole video that goes over this. My Crow's Nest video that has dual Klipper setup goes over how to start with this. I also have an article on my website. The general step is we give this internet, which gives us an IP address on our local internet, whether you live in a house or apartment or a dorm or something like that. Whatever internet you hook up to, whatever Wi-Fi you hook up to, you'll get an IP address. That's what the computer is given through the router, and that is how we can find it on our local network. So if I was to jump into a web page and put in that IP address, which is a bunch of numbers and dots, it will open up this specific device. And that's how we start talking to this. So the computer that we're using today, so I'm going to call it the host device. I'll just keep my language very succinct. The host device that we're using is what's called a headless setup. Headless setup means it's just this. This is a computer, but there's no monitor and there's no keyboard. So how do you use a computer with no monitor, no keyboard, right? There's so much stuff we can access in here, but we can't do it. We're going to do it wirelessly. We're going to use what's called SSH, which is Secure Shell. That's what it stands for. And that is a wireless way that we can use another computer, and I'll be using my laptop today, to wirelessly engage with this computer. We're going to access it, and we're going to be led to a terminal line. Let me show you what that looks like right now, actually. So this is an SSH terminal. So I'm using this program right down here called Putty, P-U-T-T-Y. It is free. I know a lot of Windows PCs come equipped with a SSH capability already, but I use Putty. I'm familiar with it, and I like it. What is my SSH then? Okay, so very simple. Looks like there's a lot going on here, but there's really not. The only thing we have to worry about is right here, host name or IP address. We're going to get that IP address that we got during the first step, which is, we skipped it today, but when we first set this up, you hook it up to your internet and we get that IP address. That is what you would have done already, and that's what we need, the IP address. For this particular device, I have to memorize it now, 192.168.1.173. I'm wrong. I think it's 175. So we'll do it again. We open up our SSH terminal, hopefully. And we put in the IP address right where PuTTY asks us to. And again, this is the way that we're going to wirelessly, thank you, communicate with this Innovato Quadra. Okay, another spoiler alert. I have a separate Quadra that's hooked up that I'm communicating with. This is unplugged, obviously. This is just really a prop. It's the same exact one, it's just over there, but I'm just using this as a prop. The Innovato Quadra clearly has to be plugged in and powered on for it to be receiving internet for us to access it. So again, this is a prop, I'm just showing it for the sake of this video. But what I'm trying to do is wirelessly engage with this Quadra that's sitting over there. And we're doing that through SSH. I put in the IP address that I was given during the installation process, and I have 2 videos on that, so we can go watch that later. And now we have to log in. All these devices come with a login ID. The Pi is usually Pi as a login, password Raspberry. The Quadra is Quadra as a login. And this comes with the device. When you open the box, it gives you all this. And the password is Innovato with a bunch of numbers. We put in our login ID and we put in our password, and we are now in. We are in this computer. This is just like my desktop right back here, right? So if I was to double click this folder, it opens up. It's the same thing here. I'm at a terminal line and I can do a lot of the same things. So instead of opening up a folder, I write CD, change directory, another word for folder, CD Klipper, and I hit enter. I've opened up the Klipper folder. Obviously it doesn't look like it, but that's just all we're doing. This is a terminal line based or command line based operation. It looks like we're hacking something. We're not. We just have no user interface. This is just a bare bones way of speaking with this computer. I'm going to show you all the text and all the copy and pastable data you need. So don't worry. I just want you to understand where we're at. We are currently logged into our computer, our Innovato Quadra, and I am going to tell it things it needs to do in order to install Klipper onto it. So yeah, the Innovato Quadra as a host is actually very fast. It's very, you can host multiple devices on it even. So this is a really good device. So we're SSHing, we're wirelessly communicating with this device right now at the terminal line. We're right there. And I need to run a few commands. I've forgotten all these commands, so you're gonna see me jump to my website a bunch. The first series of commands is going to make sure that we download from the internet certain packages and files that we need. These are all copy and pastable. You're gonna see me doing these things, and it's so simple, I promise you. So let's go to princeleO3D.com. How's that? This is where I have it. This is the reason to have a website, so when you do things, you can remember them. Go to my articles, and I have one on the Innovato Quadra. Here we go. Okay, I go over the installation of getting the IP address, all that stuff right up here. And now, the first lines of getting Klipper onto our 3D printer. We're going to be running using Kia, which is K-I-A-U-H. It's Klipper Installation and Update Helper. Before Kia, we did everything on the terminal line by line. It could be a little confusing. Kia has made this process so simple. You're going to see. We have a simple Innovato Quadra right now. There's nothing on it, and in about 4 minutes, we're going to have Klipper on it. It's that simple. But these are the lines we're going to run. Sudo apt get update, sudo apt get upgrade. So sudo is just a user that we use to implement these lines in the terminal. You don't need to worry about any of this stuff, really. I've simply copy and pasted. Come on, Ed. I've copied these 2 lines. I'm going to go back to my terminal, and I'm going to paste them in. The way we paste is by using the right click on the terminal line, and those lines have been pasted in. I hit enter, and it executes them. It's going to ask me for a password because we're doing some updating. I put in the password for the Innovato that I knew, and it downloads all these files, all the packages, and it's doing what I asked for it, which is getting files from internet, updating them, and then installing them. And that's what we need to do before we do any sort of installation, just to make sure everything is up to snuff, so to speak. So I've done this already, so it was really quick. Oftentimes, this may take 5 to 10 minutes when you download stuff and install it. But so far, all we've done is SSH into here, and we've copied and pasted 2 lines. That's it. The next thing to do, and those are basic Linux or computer-based lines. These are really Klipper agnostic. These are just things you want to do when you first get something like this to make sure everything's running up to speed. The next line we're going to run is Git. So Git is something that Kia, the interface we're using to install Klipper, needs to use. You don't even need to know this. All you need to know is hit copy on this, go into the terminal line, right-click to paste, hit enter. This is now going to download and install Git which is what the program we're going to use in a second, needs to run. Again, I've done it already. It took about 3 seconds. Normally it takes some time though. So we know when something is finished also because you can see right here, this line before the semicolon, that means the computer is waiting for me to input something to execute, to input a line to execute. So whenever the line right here is available to us, that means the computer's not doing anything and it wants something, it's waiting for us to tell it to do something. Fair enough? We have now updated our little single board computer. It's ready to get Klipper installed onto it. These are the next 3 lines we're going to run. The first one right here is CD, change directory. We're changing directory. We're just opening a folder. Instead of double clicking on a computer, this is a terminal line. We're just writing CD. And then we're going to a GitHub. We're going to copy it, and then we're going to open this terminal, this program, as you'll see. So again, we're copying this, right-clicking to paste. That's it. I'm explaining a lot of words, and I apologize, but really all we've done is SSH'd into this. We've copy and pasted like 4 lines. That's it. I hit enter, it executes, and I opened Kia. Kia's asking if I want to update. I don't want to do that right now. I would recommend not doing it just the first time. And now we are in a main menu system, and this is going to be easy to navigate because it kind of tells us what it wants us to do. So the numbers right here to the left side are all selectable. And to the right side, these are all programs or items of Klipper that are installed or uninstalled. Now, because this is a Quadra I've installed all this stuff already. If this is the first time for you, this not installed in red is going to be on every single one of these. Now, Klipper is a 3-pronged item. So Klipper is a trident, basically. It needs 3 items to operate. One is Klipper itself, and that's right up here. So it tells me that I have Klipper installed, but if you have a new device, you wouldn't have that. It would say not installed. That means we need to install it. Below that is Moonraker. Moonraker is what Klipper needs to communicate with us. So the trident, the trinity of Klipper is Klipper, us on our front end, and Moonraker in the middle. Klipper sends information to Moonraker. It translates it to information we can understand, and it sends it to us. And then when we send data to Klipper, it goes to Moonraker, it gets translated to Klipper's language, and it sends it back down there. You don't even need to know this stuff. Just kind of, if you want to know it, that's the holy trinity of Klipper. Us, Moonraker, Klipper. This is the communication triangle. We don't, and I don't know if I mentioned it before, Klipper no longer uses the screen. Screen's out of here. So the screen is an encoder. So if you run the knob on your screen, it's an encoder. Klipper doesn't work with an encoder. So basically that just means Klipper doesn't work with the screen. Klipper has to work through this interface that we're using. It's going to be a web page. We're going to send directions to Klipper. It gets translated by Moonraker and then sent back down to Klipper. You're never going to know any of this stuff. You're just going to click a button that says like heat my hot end up, and it's going to do it. But it is doing all of this stuff. It's very, very cool, so you do know it. So back on to the second one. Moonraker is the middle of the trinity. That needs to be installed. And then under Moonraker is one of our front ends, either Mainsail or Fluid. I'm not even going to count Octoprint. Mainsail and Fluid are our new screen, if you want to call it. That's the user side of the trinity. The way we interact with Klipper is going to be through one of these front ends, either Fluid or Mainsail. They are very, very similar. I personally use Fluid. Whatever you want to choose, obviously, is up to you. You can choose them both. You can use them both in tandem if you want. See what you like better. I like Fluid, but again, either one you choose, you're going to absolutely love. Where did I hear about the Quadra initially, Colin? That's a good question. I have no idea. I really don't. Maybe the Klipper subreddit? It was not a lot of buzz about it when I first heard it, so I honestly cannot recall. With my memory, not even trying to recall. Okay. Holy trinity of Klipper is Klipper, Moonraker, and our front end. I'm going to use Fluid. So we need to install those, and we start with the top end, which right here is Klipper. So from this menu, we can see a list of options right here to our left. One says install. Which one do you think we're going to use? We're going to use install. So I hit 1. You can see it right down here populates. I hit enter, it executes it, and it brings me to the menu for install. It says right here, installation menu. Now, what am I trying to install? This gives me all the different things we can install, and there is a lot of them. Well, I want to install the first prong of Klipper, which is Klipper. I hit the 1, because Klipper is right next to this 1, and I hit enter. And now, well, Klipper is already installed. That's the problem. So after that, we would go through the entire process of installing Klipper. It's literally 2 more hits of the enter key. Klipper downloads its files, its directories, and installs it onto this device. Right back out to this installation menu. We do the same thing with the second prong of Klipper, Moonraker. We go to number 2, right? Moonraker is number 2 on this menu. That's what we select, and we install Moonraker. Same exact thing. I hit enter. It asks how many instances you want, how many 3D printers do you want, instances, 3D printers. You hit 1, you hit enter, and it installs everything. Below that, Klipper Web Interface. This is our front end. This is the user-facing side of Klipper. Which one do you want to install? Mainsail or Fluid? You pick whichever one you choose. I usually choose Fluid, and you install one. I'll actually install Mainsail right now because I don't have it. You can see the process. It's very, very simple. I click 23. I click 3 for Mainsail. I hit enter. Brings me to a new menu. Fluid is already on a port. You don't need to know this because you're not going to install both. This is just telling me that I need to select a new port for Mainsail so they don't interact poorly. I'm going to pick 81, just 1 port up. I hit enter again. This is what it looks like when you install any of these front ends. It goes that quick. It installs like that. And then it's going to ask me a very important question. Download the recommended macros. Always yes. Macros are like little recipes for Klipper. It has a title and it has things to do with that title. Title is French onion soup. It has a list of ingredients and then how to make it. That's what a macro is in Klipper. It'll be have a title and then it'll tell Klipper what it wants to do with whatever we give it. So we want the recommended macros. It gets us started off in a very positive way. We don't have to go looking and searching the web for them. So we always hit yes. For this yes or no, whenever you see one like this, whichever is capitalized, if you hit enter, that's what you're going to select. So I hit enter and it selects yes for me. Yeah, I don't remember exactly when I found out about the Quadro, but there was a time when I did. And I really liked it. The Wi-Fi is a bit of an issue. You have to buy a little Wi-Fi port for it, but it is what it is. Okay. We are literally done. This has Klipper installed on it, Mainsail installed on it, and one of our front ends, I chose Fluid and also Mainsail, you saw. So we're completely finished. This has Klipper, and it's ready to go. If there was a 3D printer down here, and there's a lot, that have Klipper installed, I could plug this in right now, and it'll be running Klipper. It's that simple. But let me go back, let me pull out here. But our Ender 3 V3 SE doesn't have Klipper installed. This is ready to go. This is ready to go. We've installed the 3 prongs, the trident of Klipper, Klipper, Mainsail, and Fluid or Klipper, Moonraker, and Fluid or Mainsail. Those have just been installed. Again, I shortcutted it because they're installed on my device already, but it would be almost just as quickly. This installation really is that simple. We select the number of what we want to install, we hit enter. It's going to ask you a few questions. How many printers do you have? Do you want to do yes to everything basically, and it installs. We do the same thing with Moonraker, and it installs. We do the same thing with our web interface Fluid, and it installs. It's that simple, and this is now ready to go. This is a Klipperized host device that can power very many printers, actually. The problem is Klipper onto our 3D printer. This is still running Marlin. The main board is still Marlin based, so we need to compile firmware for Klipper and flash it on. How do we do that? We're going to use this device. This is going to also let us flash Klipper onto our 3D printer. How do we do that? Let's jump back into the terminal and find out. So I didn't go anywhere. We're still in the terminal. Did I switch to the screenshot then? So I didn't go anywhere. We are still in the terminal. This is where we last left off. We just installed Fluid. I'm going to back up. I do that by using this B button right here. I don't click it, of course. I just input a B and I hit enter and it backs me one menu up. Now I want to go through, and you can see right here, for you would have not installed on all these. Klipper would now be installed. It would look just like mine. Moonraker would be installed. And then either Mainsail or Fluid would say installed next to it. This is a really great way of keeping up to date with what you have installed and what you do not have installed. So we've installed the 3 horsemen of Klipper. Now we need to flash it onto our computer. This Kia main menu is going to help us do that. And we do that by going to the advanced menu, number 4. Click on 4, or I input 4 and I click it. Now we have this advanced menu that opens up. We're looking for firmware, and we want to build only, meaning I want to build the firmware, but I don't want to uploaded or flashed anything. I'm going to do that separately with an SD card. That's how these Ender 3s are flashed. So we go to build only, I input 2 and I hit enter, and now you'll see this new menu opens up. And this is like what we call a configuration menu. I actually think it's already set up properly. Let me get rid of this. When you first open it up, it's going to look just like it does right here. And all this is, it's basically like another menu list. We just need to check off the proper settings for our computer, for our 3D printer. How do we find that? Well, we got to go to the Google usually. We'll Google what printer we have or what main board we have, and it will tell us what the correct settings are to set up for this. When we flash Klipper onto a 3D printer, we're flashing onto the main board specifically. So for instance, if this SKR Mini was in the Ender 3, I'd be flashing Klipper for an SKR. This has some Creality board in it, so I need to find out what it is and flash Klipper onto that board specifically. So when we flash Klipper, it is specific to the main board, not to the printer, and that is a very important feature of Klipper. We don't need to worry about what kind of hot end this has, how big is the build size, what's the max temp. That is stuff we're going to worry about down the line. It's going to be very easy to configure that. Right now, we just need to know what is the main board in here, and then from there, we can find out how to flash it. I'm going to show you the powers of Google. Some brave soul has Ender 3 V3 SE. Oh, probably should put Klipper next to it. So this first Reddit thread is someone that has installed Klipper on their device and shares with us the way to flash it. So I click on the link. I then click on his GitHub, which is what this website right here is. It hosts different things for us. And from here, I can go into, can you tell me on the front page? This .cfg document. Any document in Klipper that ends in .cfg is a configuration file. It's telling Klipper to do something or how it wants something done. We're looking for one that's called printer.cfg, which is right here. They've added a few more words to it, probably for some sort of naming device. Open it. And right here at the top, it's going to tell us how we need to set up this file to flash this particular main board. I've done this research already, don't worry, it's going to work. So this file contains pin mappings for the stock 2020 Reality 2022 Ender 3 V3 SE, which is what we have. To use during the make menu config, which is what we call this screen right here, the make menu config. Again, don't need to know that, but if someone's referring to it, this is what they're referring to. It wants us to select STM32F103. So, oh, that's a lot to understand. Not really. Look, it's right here. Architecture, STM microelectronics, STM32. These are all the different options we have. It told us STM32F103. So I go to STM32, hit enter, it selects it, and then down to processor. Look, F103. So if I hit enter again, it's going to open up a larger menu, and you're going to see there is a ton of different STMs to choose from. But this told us to choose STM32F103, and that's what we'll do. I hit enter to select it, and we can move on. And it said to do this with a 28KIB bootloader. Okay, bootloader is directly under this. If I hit right on this, and I'm using the directional pad, it opens up a larger menu, and you can choose different bootloaders. Again, this is a lot of information, but they're telling me literally what to do. Just showing you what options we have available to us. So, 28KIB bootloader is what they told us to choose. If I wanted to choose a different one, I would just hit right on it. So I'm using the directional pad, I hit right to enter the menu, and then once I select something, if I hit right again on the directional pad, it selects that, exits me out of the menu. That's the way we choose these things. So bootloader offset at 28KIB, which is what this says. I'm literally just copying someone else's work right now, right? And then serial on USART PA1, on USART PA10/PA9. So communication interface, which is the next one. Right? Communication interface, which is the next one. It wants us to do it on USART 1. So if I go down to communication interface, I hit right, it opens up a larger menu, and I only have 4 options here. One is serial, PA10, PA9. That's what they want us to use. So I highlight it by just going up and down with the directional pad, and then once it's highlighted, I hit right on the directional pad, and it chooses that. So now I have this set up just like this is telling me. We need STM32F103, 28KIB bootloader, and the communication interface, serial USART 1, PA9, PA9. Again, we've just copied this stuff. If you have an Ender 2 or Ender 3 Pro or something like that, you're going to Google it. You're going to find the same exact document. You're going to find someone who has set this up. And this is exactly how you do it. It's very, very simple. It's all out there. Once we have set it up properly, we hit Q. That's going to prompt us to save the configuration. We hit Y. This is all on our keyboard. That saves that configuration and compiles it for us. So this is creating the Klipper firmware that we need for this printer. It's going to happen very quickly. And then once it's done, it's going to finish with a firmware.bin file. Just like a Marlin firmware.bin file, we're going to move it to an SD card, and we're going to flash this 3D printer with it, and that's going to have Klipper on it. We're almost there. It's very, very exciting. Yeah, so Hunter, correct. You can CD Klipper, which is CD, change directory, Klipper. So now we've changed directory to the Klipper folder, and once you're in that Klipper folder in your terminal line, you'd run make menu config, and that would open that up. What we're using is Kia, though, and this is a gigantic help to us. Kia, K-I-A-U-H, Klipper installation and user helper, kind of does all this work for us. The way I got to it, I didn't use make menu config. I'm going to back up. First, let me just show you. Our firmware is built. It told us, right? No errors. Everything's great. So we now have firmware. How do we get it? We're going to go over in the next step. But to show Hunter very quickly, so this is the Kia main menu. This is what we used earlier in the video to install Klipper, the 3 prongs of Klipper. After we installed Klipper on our host device, we needed to create firmware and flash it for our 3D printer. I did that by going into the advanced menu, which is right here, number 4. And then from the advanced menu, I wanted to build firmware. Only build it, because I'm going to flash it separately. So I hit number 2 on my keyboard. I hit enter, and that opens what we call the make menu config menu. And that's how I created this firmware. And then, of course, we created or compiled the Klipper.bin. So now that we've compiled our Klipper.bin, our firmware, we need to get it, put it on an SD card. Really what you need to do is flash it onto your 3D printer. Of course, that changes based on whatever printer you have. I know for me, the CR10 required a hex file, and you had to flash over USB. You know, different printers have different requirements. The Ender 3 V3 SE, like a lot of other Enders, we're going to take this file, we're going to move it to an SD card, and then we're going to plug it into the powered down printer. We're going to turn the printer on, and that file will be read and flashed onto our main board. Okay. I'm going to close down this terminal now. This is SSH. Again, remember, we were wirelessly communicating with this device. We're going to close this communication terminal, and we're going to open up another one. This one is going to be called WinSCP. It's the same thing. It just looks different. So WinSCP, again, free. You can download it. And we're going to be doing the same thing we did. We're going to SSH. We're going to wirelessly access this host device. We input the IP address. What was it, 175? And again, you've gotten this IP address during the first steps of installing your internet, your Wi-Fi onto this, which we didn't really do in this video. And then for this particular SSH, you remember with PuTTY, we just put the IP address in, we hit enter, it SSH'd in, and this asks us for a username and password. WinSCP just front loads that. It's going to ask us for the username right now, which is Quadra, and then it's going to ask us for the password, which is Innovato, with every other letter is a number. It's now connecting to the Klipper host device, and we're in. So on the left side of the screen, this is my laptop right now. This is everything on my laptop. The right side of the screen is everything on this host device. What we're looking for is that firmware file we built, and it's going to be located in this Klipper folder. We double-click it to open it, and then this out folder. We double-click that to open it. And then right here, you're going to see Klipper.bin. That is the firmware folder. Oh, that is the firmware file that we need to flash onto this bad boy. So all we want to do is copy it from the right side, which is our Innovato Quadro, to the left side, which is my laptop. Very simple way to do it. I take it, I highlight it, I left-click it, and I drag it over. Drag and drop. Do I have one over here? Oh, yikes. Let's rename this. So this is from a different video we did. I don't want to overwrite it, so I'm going to write Klipper 1. And so now I want to copy the Ender 3 V3 firmware from the Quadro to my laptop. I just simply drag it over to my laptop, and it copies. Simple as that. I can now close this SSH terminal down. We don't need to use that anymore. The rest of what we're going to do is open up the firmware file I just copied. Now, I brought it to my computer, but you have to know where it went. I know it went in my 3D printing file folder, and it's right here. This is the firmware file we just created. So now, what we need to do is, however you flash firmware onto your 3D printer, whichever 3D printer you're using, we're going to do that. So for this device, I'm going to install a USB drive onto my computer. We're going to put the firmware file onto this. I'm going to place it into the powered down 3D printer. I power it on and Klipper gets flashed. It's that simple. We're not doing that on, we're doing it off camera because I don't have enough USB drives to do it all. So I plug this into my computer. I go back to my laptop. Let's just say, I guess I can do it. So the USB drive gets plugged into the computer. We wait for it to populate. Maybe we make some tea in the meantime. Okay, there it is. Here is the USB drive I just plugged in. Oh, it's got a Klipper.bin on it already. I clearly flashed it. We would delete this. I'm not going to do it for now because I'm keeping that for posterity's sake. And I simply move the firmware file we created over to it. So this open file explorer is my USB drive. This one is my 3D printing folder where we made that firmware file, and I just drop it over here. I would, of course, delete this one if I was really doing this because I don't want it on there, but I'm keeping both of these for a video down the road. I would then eject this USB drive from my computer. This has the firmware on it now. I would take the firmware that's on the SD card, plug it into the 3D printer, power it on, and in about 20 seconds, the screen will turn on, it'll stay blue, and that's it. Klipper is installed on this. That simple. We can then power it off, take the SD card out, and then power it back on, and Klipper is on this 3D printer. Here's the issue. There's no communication between the two. This and this, no communication. How do we get it? Well, we're going to connect the USB cable. Let me show you how we do that right now. Yeah, so Klipper and Mainsail, very, very similar. You can download both. We did that kind of today. You can use them both if you want, see which one you like better. And then Klipper screen obviously is something that's on your printer. If you wanted to not use a web interface, you wanted to just use something directly on your printer, Klipper screen is a great option. Okay, I need to put this printer down here because that's where my host device is. Let me give you all a view of this. Okay. Plug in my 3D printer. And I power it on. Klipper has been installed. I can tell one of the main things is that the screen is no longer working. That's a great way to know that Klipper has been installed. This right here is the Innovato Quadro we've been working with. This is our host device. This has Klipper on it as well. This has Klipper. This has Klipper. This is the brains. This is going to get, the brains are going to run this 3D printer. It needs some communication. So what I do is this has a limited amount of, the Quadro has a limited amount of USB ports. So I just have an extender. That's all this is. This just gives us more ways to plug into it. I've plugged this USB cable into the Quadro through this USB port. And now I'm going to plug this into my 3D printer after I've powered it on, which I've done. That's it. The host device is turned on. The printer is turned on. And now I'm connecting the two with a USB cable. That's it right now. Is it bad to run Fluid and Mainsail at the same time? Absolutely not. You can do. You can choose both, run both, and choose whichever one you like. Okay. Let me get this camera back. Here comes the real magic. We're going to jump onto our front end, and we're going to start using our 3D printer. This is like the most fun part. Okay. It's powered on, our 3D printer's powered on. How do we get to communicate with it? Well, we're going to jump onto our front end, and we're going to start communicating. So remember that IP address we've been using this whole time? We've SSH using that IP address. That's the same address we use to access our printer from the internet. So we've been using, let me get you this. .175, the last 3 digits, as our IP address. So I just plugged the same thing in, 192.168.1.175. That's the IP address we've been using, and that's what we're going to use now. I hit enter. Don't mind this part, and you'll be brought to your front end. I have 2 printers on here. I don't want to freak you out. All right, let me do it again. I have 2 printers on that one host device. I don't want to get too complicated with everyone here. So when you input your IP address, you will be brought to the front end. Really? You'll be brought to the front end of your printer. So I have a camera plugged in already. It's obviously working. One of the awesome things of Klipper. There's my shoe, real nice. This is the front end. This is the web page, the web interface that we use to control our 3D printer. Right up top is a huge helper to us. There is a red box with a stop hand, that's telling us there's a problem. It's lost communication with our MCU. You probably will get that when you first start on, but you'll have no connection to your 3D printer. It will look very similar to this, because what we need to do is upload a configuration file. I already have one, unfortunately. The way to find one is by Googling it, like everything else, right? We found the way to flash Klipper onto our 3D printer. We find a configuration file the same way. Let's just take a real quick look at this front end before we do anything else. So this is what we call a front end. This is the terminal that's going to run our Klipper 3D printer. This is different pages that we can venture to. This is no longer a screen, right? We're not going up to a 3D printer using a screen. We're using this web page. These are pages that have individual options or different functions of our 3D printer that we can go to. And then if we click one, the right side of the page is everything that does. So this right here is the G-code preview. You're really never gonna use that. How about jobs, right? These are all the printer jobs that are on our 3D printer. So I click on that, and a whole list of printing files come up. These are everything that are on my, that have been saved to my printer. Just like we used to have with Marlin. You go on the screen, what are my print files? They're right here. Klipper has that all on this one screen. You're gonna have your history, what your previous history's been like printing with this 3D printer. All the analytics that come with all this stuff, Klipper logs that for you. So you can see all the different print jobs, the total print times, the total actual times, and the different times that all your print jobs have taken. So it's gonna give you a lot of information. Some of us, though, some of it is not accessible to us because we haven't connected the two. Our host device is turned on, our 3D printer's turned on, and there's a USB cable, but we need to give Klipper some information to each other, and that's through a configuration file. If we look at the page right here with all the dots, it's called configuration. This is one of the most important pages. If I click on it, you'll see right here on the left side, configuration files. Under here, these are all the files that Klipper is going to use to run your 3D printer. With Marlin, we compiled all the information into the firmware that got uploaded to the printer. With Klipper, you just saw, we installed Klipper onto our printer and to our host device, but we told it nothing about what the printer is. We didn't tell it its maximum bed volume. We didn't tell them the max temperatures. We didn't tell it anything, how many extruders it has. That's all done through these files. And the most important file is what's called a printer.cfg. .cfg stands for configuration. So the printer.cfg is the most important file. It's the Bible of this printer. It's going to give all the information that, that Klipper needs about the printer. How do we get it? You Google it. You used to be able to search it right through here, config examples, but some of the newer printers aren't updated. So if I had a Voxlab Aquila, I would search Aquila right here, and there is actually one now. Usually the way you do it is by Googling it or by getting it from someone else or going on the Prince Leo 3D Discord. Someone's always got something. If we go back to that GitHub we looked at earlier that had all the information on the Ender 3 V3 SE, well, you'll see right here. This is actually a configuration file. This is exactly what we need. This is going to tell us everything. This is going to tell Klipper, rather, everything it needs to know about our printer. So what I would do is I would go to the right of this. I would download this. Actually, no, I'm not going to do that. I would copy this, to be quite honest with you. Thank you. I would copy this. I'll go back in here. I would add a new file, not like that. I would add a file and I would call it printer.cfg. I already have one, so I'm going to call this printer1.cfg. You will not do that. You will simply call it printer.cfg, and then I will save it. Hello, where'd you go? Thank you. Okay, so this is the file we just created. It would be called printer.cfg, but we have that, so we're calling it printer1.cfg. I would open up this blank file, we just created it, and I would paste in all that information I just copied over here, because this is the actual configuration. This is the information we need. Someone has done all this work for us already. They've done the due diligence, and now we just get to copy and paste it. That's it. I would hit save, and then I would restart my firmware. You will have one that looks like this. It's just going to say printer.cfg. You're going to open it up, and it's going to look just like text. Might not make sense to you. We're going to break it down in a second. But this is everything Klipper needs to know about your 3D printer, how to operate it. We hit save, and now we have to jump back to the terminal because there's one very important piece, and that is the serial address right here. Serial address is just like a house address. If you were to tell someone back in like the 90s, come to my house, you know, you have Google Maps, but come to my house, you would give them your address. Well, the same thing happens with our printer. Klipper needs to know what its address is, and we get that through the terminal. We've done everything through that, right? So we need to SSH back into our host device. Remember how we did that? We used PuTTY. Am I on the screenshot? Yes, thank God. We use PuTTY. We open up this SSH terminal, and again, we're going to use the IP address that we've been using this whole time to access that host device. So for us, it was 192.168.175. Hit enter, and we're brought to the login information. Now remember, we had two SSH options. One was PuTTY, one was WinSCP. That was the one we used for the firmware. We only want to use WinSCP generally for that kind of stuff, copying files, moving files. Anytime we're trying to tell the host device to do something, we'll be using PuTTY. I hope I'm not going too fast. I hope I'm breaking this down enough. I'm trying. I did my best to do I try to paste these things well, and like all yesterday I was racking my brain how to paste this. I didn't have a lot of time. So I want to get through a lot, but I want to pace it well. I don't want to go too quick. We'll do more of these, don't worry. But for now, SSHing back into our host device to get the address of our printer. So we just fill in our username like we've been doing and the password, and we should be brought to the terminal line of our host device. Okay, unless you enter the wrong password. So we are now brought to the terminal line of the host device. Ed, what up, brother? Yeah, we're live, Ed. We're just doing some simple stuff. I shouldn't say simple. Some copy and pasting stuff, right? That's what we've been doing. We're now going to copy and paste, or just paste in a very simple command. You don't need to know what this does. You're just going to do it. Very simple. It's ls/dev/serial/by-id a slash and then a asterisk. That is the line that's going to give us the address of our 3D printer. That's it. It's going through different folders and it's giving us the address. I hit enter to execute and I get a return. If you get a return, pardon me, if you get a return, that means Klipper has successfully flashed onto your 3D printer. The host device and your printer are communicating. Klipper just asked, what's your address? And the printer just said, this is my address. That's it. What we would normally do, again, we're flying off the seat of our pants here, is copy this right from here. So I highlight it, hit control, I hold control and I hit C, it copies it. I come back into my serial and I just paste it in. Control V and it gets pasted in. Simple as that. Here's the one thing. For this device, I'm running two printers on it. If you might run into this yourself, let's say you have two Ender 3s running on the same host device. Guess what? They have the same address. 105, Merrick Parkway is the Ender 3, and this Ender 3 is 105 Merrick Parkway 2. They are every Ender 3 off the assembly line with this main board has the same address. That's a problem. Klipper needs to know which one's which. How do we differentiate it? For us, we use a different command. For people with multiple printers, you would use the similar style, ls dev serial. Instead of by ID, which is the ID, the address, we're going to use by path. Bypass means it's giving us the address through a particular USB port, right? It makes a lot more sense. If we have two USB ports and two printers coming in, they have the same address. Well, now we can differentiate them by, okay, this sender 3 is using this USB port, this sender 3 is using this USB port. So when we have multiple printers, this is the line we use. It's very, very simple. As a new person to Klipper, you probably will never run into this because you're only doing a single instance. We hit enter to execute this, and I get a return. So I'm getting one return. I should get two, right? Because I have multiple printers. But the other ender 3 is not plugged in or turned on because it's very loud. So I would get two results from this normally, and I would do the same thing. I would copy it from here, and then I would paste it in. Of course, I've already done that. And this is the return. Same exact return, right? USB 01110 port 0, USB 01110 port 0. So it's the same exact line. That's the address. Once you have the correct serial address, we're basically ready to go. That's the only thing we need to add to a configuration file that we get from the internet, the address of our printer. And even sometimes it comes with it, but in general, we have to add it. So we've made an amendment to this configuration file. There's a dot up here that lets us know that we've made an edit. What do we do next? How does Klipper read this? Very simple. We can save this, or we can save and restart. Save and restart is the king of Klipper. When we save something, backtrack. Klipper reads all its configuration files once when it starts up. So if I make a save to this, if I always edit this document and save it, Klipper doesn't care. Klipper only remembers what it saw when it first started up. So if I make an edit to this document that needs to be uploaded, needs to be changed, I need to save it and I need to restart it. That's the end all be all. It's a lot of words to say that. So I made a save to this. I made an edit to this serial address. I want to save it and I want to restart Klipper so it uploads, so it takes that new edit, that new information. So I save and restart. And the red box up here is going to go away because I am communicating with Klipper. That's it. I'm in. We're in. We've done it. We have a 3D printer, an Ender 3 V3 SE that is running Klipper. That's simple. Now back to this pages bar. Let's go to the home page. And you can see if I roll over these slow, it tells me what all the pages are. I click the home page, and the home page is kind of like what you would expect in any home page. Let me move this camera. The home page is a home page you would expect in just about any device you use. It's going to have all the pertinent information there for us. Let's just take a quick tea break. If you got to get a brownie, if you got to do your thing, now would be the time. What's going on with the music? Is it too loud? I just run background music during the, just because my voice is awful and you guys shouldn't be subject to that constantly. Which, oh, yeah, Google. Google Skynet, what do you want it to do? What do you want to know? It is what it is. We're all using it. Okay. We have our host device on. Our 3D printer is on. They're all running Klipper. It was that simple. I mean, I spoke a lot. I explained a lot of niche things. But in the end, I didn't do a lot. I just copied some things from my website for one. Then I went to some gentleman's GitHub, copied some of that. It was very, very simple. It's all stuff we could have figured out. How do we just talk to Skynet for about 5 minutes? Let's go back to our Klipper front end, see what's really going on in there. Okay, this is our Klipper front end. This is the screen that we wish we had but never did with Marlin. This is going to give us all the pertinent information of what is going on with our 3D printer. Right up here to the left is the current print job or the previous print job, whatever's happening. So I'm at idle right now, there's nothing printing. These are the past print jobs that I have done. Read them all from there. If you were to install a camera, which is very simple using Crow's Nest, the drop down would show up right here. I have a camera installed now. It's looking at my 3D printer. I can now watch this from any room in my house, and when I install Octo Everywhere, any place I am on the earth, I can watch what my 3D printer is doing. I can make sure it's doing it properly. And I can minimize any of these menus, obviously, as I see fit. Tool, very important one. This is how we move the print head around. I think with Marlin, it used to be called Tune maybe, or Prepare. You used to hit Prepare, and then, oh, X-axis, right, whatever. This is that exact menu. This is going to give us a little more information. So this little snowflake lets us know that We can't extrude filament if we wanted to because there's a certain threshold that we are below. And that's all stuff that we can change ourselves if we wanted to. So let's take a look at our 3D printer, and I'm going to home it, right? G28, if we wanted to home all the axes, let's make sure it's all working. I go to the tool section. That's how I move the tool head around, and I click this button, home all. And you'll see when I did that, something populated right here, G28. So this is called the console, and this is where the rubber meets the road, basically. For us, this was a button push. It's UI, right? But for the console, for Klipper, it turns that button push into the actual G code, G28. So this is a really great way to understand what's happening with your printer when you can kind of see what the physical buttons are saying to the printer. The more you see G code, which is what that G28 is, the more you kind of familiarize yourself with it. So we hit home all axes, but the real command is G28. That's what Klipper knows it to be. So that's what it did. It homed. Did it home for us? I didn't even hear it. It homed for us. Now, if I wanted to move the tool head around, I would use these directions. So as you hover over things, you're going to see obviously little tooltips show up. Left to right is the X, front to back is the Y, and then right here I have the Z. These are the increments of which I can move it. If I wanted to move it right 25 millimeters on the X, I could do that. And you could see the print head is moving. At some point, I'm going to get too far. And right here, I'm going to get a movement out of range error. Klipper is telling me that the movement I just asked it to do exceeds the max range. And all the errors that pop up in Klipper are going to be accompanied by a similar error message or error box, and we can very easily diagnose what's going on. For instance, movement out of range, it then tells me the coordinates that it's trying to go to. One of those is above the bounds of where it should be. Simple as that. So if you come to the Discord, if you have a problem, you show us something like this, we can immediately tell you there's a movement out of range error, and in this case, I can tell that it's probably the X, which is the first number, X, Y, Z. The X coordinates are too high, you're probably going past your bed. So that's just something that Klipper offers us. And then right here, it also gets spit out in the console what our error was. This is an error message. Below that, jobs, print jobs, all the different print files that we have available to us. These are normal things you would expect to find on a home screen. The fans, the different fan. I want to turn the fan on right now. Guess what? I can do it. Fan's going on, very loud. So we have all these controls on the home screen. And not only that, we can configure this home screen however we want. If we go right up to here, to the right, and we go to adjust dashboard layout, we can start adjusting how we want to see this dashboard. Just for your own convenience. Let's say you want to see the thermals and the camera all together as one. We would use these little dots to the right, and we would drag them around. We want the tool head as four little things, as four unique columns. We could do that too. After we exit the layout, you see it's changed now, right? It looks a lot different. Things have shrunk because that's how we set it up. You can set this up to whatever your heart's desire is. However works for your workflow, set it up that way. Keep in mind that you can also access this on your phone. Any device on your Wi-Fi that can open up a web page can access your printer now. So if I opened up my phone and typed in 192.168.1.175, I would have the same screen we're looking at right here. Now, of course, you got to keep in mind it's a phone screen, so it's going to look a little different, just because it's compressed. But it's the same thing, so I can communicate with my printer through that. It's awesome. Let's change this layout because it's a little let's do 3. All right, what else do we need on here? Simple, right? Actually, I like 2. So just adjust the layout however you see fit, however you see comfortable. Actually, let's reset to default. Thank you. We're back to our default layout. Whatever you feel comfortable with, but we get that option to kind of change things around however you want. So now, let's take a look at one of the most important pages. So all these pages right here, history, jobs, tune, configuration, very important page. It houses all the configuration files like I spoke about before, the printer.cfg being the most important. I want to click it, I want to open it real quick and show you. Oh yeah, Mobile Raker and Octo Everywhere is amazing. There's going to be a video very shortly on it. It just does everything you want for complete free. And the price of free. Okay, so here we go. Printer.cfg, we're opening up. I want to show you what it looks like just because, you know, some people think this is like code and like I'm looking at the matrix right now. It's not. It's so simple. This is a text document. Let me show you the same thing. I'm going to download the printer.cfg. Download printer.this document. This is it. It's a text document. Please no. Please no. All right, minimize, better. Okay. So if I open up the printer.cfg, you'll see it looks wacky. It's literally a text document. Include all these little, where are we? There we go. So it looks scary on the left side, the darkened side with all the color. This is just a text document. That's all it is. Speeds and excels. And the way Klipper kind of illustrates it for us just kind of fancies it up. It helps us. So within this configuration file is, like we've said before, I've said a million times, everything Klipper needs to know about your 3D printer. Let's go to speeds and accelerations. Commenting, very important feature to any of these documents. This is all computer language, if you want to call that. It's Python based with a Jinja 2 template. You don't need to know any of that. What it means is that just this is language that a computer is going to read. If I want to make a human comment like kinematic, Cartesian, but really this is core XZ. I don't know, just for someone down the road, you want to make a comment. If I was to write this and save it and let Klipper read it, it would have no clue what I'm saying right here. I'm trying to tell someone something that might open this file later on the road, but I'm doing it in the wrong direction or in the wrong manner. What I would want to do is what we call a comment. You see all these things are gray, and right here it's gray. That means it's commented out. Anything after a hashtag or a pound sign, whatever you can call this, I'm old so I call it a pound sign, anything after this comment sign will not be read by your 3D printer. And that's why you see all these grayed out sections here. They're for us, the user, to understand what's going on. If you want to make a note like, hey, Max Excel 5000, but really it was 7K and I throttled it because it was killing, because it was loud, because of noise. Jeez Louise. So that's the way we call it commenting out, because it's the way to leave comments for either yourself in the future or other people that might be reading this. So commenting is a very important feature of this printer.cfg, because if we want to turn things on or off, we can just comment them on or comment and out. Kind of a cool function to have, or kind of cool feature to have. Let's take this first section here. So this is, at the top, you'll see there are brackets. Anything in brackets that is a different color is a setting or a feature. This is the printer one. Under that is a bunch of text right here. And then you'll see more brackets down here. Anything under a word that's in brackets is part of it. It's part of those features. And Klipper is very, very handy because it gives us help documentation right above everything. So the setting right here is called printer. If I want to know how it works, I can click on this link. It'll open up. Oh my God, wow, we're in the Klipper configuration for the Klipper documentation, and it tells me how this section works. I should say, I mean to say the word, I'm saying features, there's sections. So under this printer section, I have different categories that have been filled out for me. These are things that you could alter down the line, but in general, there'll be some really good starting points. So kinematics, you don't need to know. Max velocity, max speed. We get to change that if we want to. It's right here. Max acceleration, just what you think it is, right? Speed is time over distance, right? Time over distance. Like velocity is time over distance with a direction, and acceleration is velocity with time, right? Time over velocity. Doesn't matter. Okay, anyway, so we get to change all that stuff. You can make all these changes. It's just a text document, and the colors are just there to help us, to let us know, like, all right, the whites, the left side that's white is one thing, and then the answer to it on the right side is orange. If I was to put something else, or if I was to comment right here, again, you'll see it's a different color. It's just easier for our eye to identify all that stuff. Every section is kind of self-evident. Input shaper, what do you think this covers? It covers our input shaping. So this is the name of a section, input shaper, it's in brackets, and all the text under it is going to be part of that section. And these are my input shaping features. So I've calibrated input shaping on this printer, and I house it under this section. If I want to understand more about this, I can click on the documentation, opens up to the input shaper section, and I can see these are the settings and what they're doing and how they're doing them, right? So shaper type, MZV, and it tells me a little bit about it. Well, if I go back and look, I have it right here. Oh, shaper type. So it's very easy to understand what's going on because kind of the documentation tells you how to do it. I wish I had prepared for this section more because the printer.cfg, the configuration file, is very important. Actually, did I add the article yet? I'm going to have an article about the configuration. I did a bunch of work at some point on this. I didn't know that. And I made some slides and something like that. It's going to be an article on kind of the configuration file and what it does. But if we look at it, I'm going to scroll very quickly. It's not a very long file. It stops right here. This is it. This is all the information Klipper needs to know about our 3D printer. It's not a whole lot. It needs to know general printing things. Max speed, max accelerations. Input shaper, something I've added. Our stepper motors. So it needs to know stuff about the x-axis, stepper X. The y-axis, stepper Y. And the z-axis, or the height, stepper Z. All the information is housed under those sections. In Marlin, if I, made an amendment to, or if I changed my max Z height to something bigger, 250 is, I think, the base box lab kilo height. If you did the ender extender, you made it 350. You have to recompile your firmware on Marlin, recompile it, get all the proper information, get it onto an SD card, flash it like we did with Klipper, and you have to do that every time you make any addition. If I want to make an addition with Klipper, let's say I made the Z height 500 millimeters on my Aquila. I come to stepper Z, because that deals with Z height, stepper Z. I come to the position max, and I change it to 500. That's it. I can now save and restart my firmware, and when it restarts, when this error bar goes away, the new max height of my 3D printer is going to be 500 millimeters. That's it. We've just changed the height of our 3D printer, and it was that simple. It was just editing that text document. Now, if I was to home this, if you want to see me grind it, I will. I'll shoot this to 500. It'll just stop. Maybe I won't do that. Now, though, the maximum position of my Z-axis is 500. I just made that quick edit, and I was able to do that. Klipper allows us that. I want to go back. I want to change it. I'm at the home screen. I have to find that printer.cfg file, right? That's the lifeblood of this. So I go to configuration page. I find my printer.cfg. I open it up, and I go back to stepper Z, and I'm going to change it back to 250 because that's really what it is. Save and restart, and now Klipper will restart with that new information that the height of the Z-axis is actually 250. So changes, additions to Klipper, so simple because we just edit this text document. Now we keep going down. Extruder. Well, what do you think the extruder is? Anything on your hot end, anything your extruder controls is going to be housed under this section. Minimum temperature, maximum temperature. Maximum temperature is a big one. I mean, like 2 years ago, I remember when I was getting emails constantly about people adding all metal hot ends to their printers, and they wanted to up their max temperature. For Marlin, you had to recompile everything. I needed to know if you had a BL Touch, if you had a runout sensor, how big your bed was, what are your X and Y. I needed to know everything. And then I would up your max temperature, recompile it, and send it to you. For Klipper, I simply erase 260, I hit 300, I save, I restart Klipper so everything takes effect, and now the new max temperature of my 3D printer is 300. If I go to the home page, if I go to the thermal section, you'll see I have an extruder section, so that's the heat of my extruder. It's currently at 23 degrees Celsius. I have a heated bed that's currently at 22 degrees Celsius. If I wanted to change one of those temperatures, I would just click on this box, and I go to 285, enter, and you'll see there's a heating command that has populated in the console. And in the thermal section, it has raised my projected value to what I put it to, 285, and I start heating up. Simple as that. I mean, that's how we heat. Thermal runaway protection, very important protection that some Marlin printers had, some didn't have. Klipper comes with it stock, meaning if for some reason your thermistor is not registering the proper temperature, let's say it's just reading 35 and your temperature is increasing and increasing and increasing, and it's broken, it fell out of your heat block, your thermistor, which is what detects temperature in your heating block. If you don't have some protection against that, your heat will continue to rise because it's still 35 degrees. Thermal runaway protection is the protection against that. After a certain amount of seconds, if the heat is on and the temperature hasn't increased, it realizes a problem and it halts your printer. Some Mullen printers had it, some don't. Klipper always has that. So for some reason, the thermistor had fallen out of my hot end or it's not reading properly. And I put this to 285 and there wasn't any increase in temperature after like, I think 15 seconds. This would halt my temperature, halt my printer. It would turn it off as a safety feature. The Klipper has also that built in. So you'll see, we are now heating up to 285. We made that amendment very quickly in a printer.cfg, and now we see it self-evident. Back to the configuration file, back in printers. Now, let's just go over some of these other files. Some of these are things I've added myself. Some of these are just files that get added when you first install Klipper. You really don't need to open any of them. A lot of these other things are just stuff that I've done. For instance, let's say I want to add some stuff about an input shaper, right? Generally, there's other sections we need to add. Well, instead of just kind of gumming it all up in this one file and I have to like scroll around and do a lot of scrolling, I create a new file. It's just simple, right? So I create a file called, where is it? Input shaper, I think. I just create a file called input shaper. And it's right here. It's very simple. And now I've compartmentalized it. Love that word. And all I do is I go to printer.cfg, our Bible, our lifeblood, and I include it. It's right, where is it? It will be right here. So it's commented out, meaning it's turned off. And if I erase that comment, well, that's turned on then. And I would save and restart. Klipper would know that, and it would turn it on. It's a very easy way to keep this document very clean. So something to think about. I mean, it's not necessarily user or beginner based, but this is Klipper. There was no coding we had to do. We copy and pasted everything. We found this configuration file from the internet and we uploaded it. We pasted it in. Simple as that. So let's say I want to do PID temperature tuning. Whenever you get a new printer, you should always run some sort of PID control. It calibrates the temperature for your particular environment, for your particular basement or loft or wherever 3D printer is housed. So there's no onboard method to PID tune with Klipper, but we can create what's called a macro and do it ourselves. Macros, like I said, are recipes. They're sections. They have a title, and then they have a group of commands that we want Klipper to execute. Now, this is crazy. It's a lot. We have to write this. We don't have to do any of that. We can copy other people's macros and use them for our own. I have a PID tuning macro that I use for every single one of my 3D printers. It is this simple. It is these sections right here. I copy them from one printer, I move them to another, and then I get to use them. There's nothing else I have to do. Simple as that. And the best part, so let's take a look at just the first macro that's right here. G-code macro, that's how we know it's a macro. It starts with this definition in the title, and then the name is right next to it. PID tune hot end. You can name it whatever you want really with no spaces. We save it, we restart it. Under here, it's telling us to calibrate the PID, turn it into a macro, close it. Anytime you turn anything into a macro or you create a new macro, it's going to now show up on your home screen as a clickable button. It's very, very simple. So on my home screen, if I find the macros section, any macro I've created or I've copied from other people, they will be available to me right under here at the click of a button. So if I find that PID tune hot end, here it is. And it even has a drop down. I can select what I want to PID tune my hot end to. PID tuning is best tuned to whatever you're normally printing at. So if I'm printing at like PLA at 225 degrees, well then I would choose to PID tune this at 225. I hit send, and that operation happens. Right here, where is it? Right here, PID tune hot end, temp 225, and it's going to happen right here. Very, very simple stuff. Everything can be executed from either button clicks or through the console. And everything we get, all the information that we gather and put into our printer configuration file, is usually copy and pasted. It's usually from someone else. I mean, it's very, very simple. I hate to bust everyone's bubble, but it's not that hard. For instance, we have a camera hooked up to this. It was through the addition of a single file. Crow's Nest. I almost said Moonraker again. Where's my Crow's Nest file? And these are all just text documents. I'm scrolling through these. I don't want anyone to be scared by any of these. So you'll see multiple printer.cfgs like this. So printer, and then it's a date, and then a CFG. Anytime you make an edit to your printer.cfg, Klipper will make a backup for you. Just in case you've made a mistake, you can always roll it back. So you'll see a lot of these. There was at some point, I think, a way to hide them. I don't remember how to do it anymore. I think I have to do it somewhere else. It doesn't matter. So this looks a little bloated, a little more bloated than it should, simply because every time I save and restart with an edit in printer.cfg, Klipper is making me a backup to make sure I'm not a dummy, because they know I am, and we can always roll back to a previous configuration file if we need to. Oh, that's right, it's on the other one. We're looking at the pages here, right? So we have our home screen. You're going to spend most of your time here on the home screen because we can watch our printer. We can see what the jobs are doing. We can see what our thermals are doing. Right now we're running a PID tune. Our console is telling us various things. We can select print jobs from here. So the home screen is generally where you're going to spend most of your time. The configuration tab right down here, I would say, is next where you're going to spend the rest of your time on the front end, just because you'll be doing a lot of changing to the printer.cfg as you update different things. This tune menu, you might think we're tuning certain calibrations or pressure advantage or input shaping or whatever these Klipper calibrations you may have heard of. We're not. This is simply for bed probing, and if you have a filament runout sensor, it would be right down here. So we have a bed probe on this 3D printer. I'll run a bed mesh momentarily after this PID tune is finished, and I'll show you how we now get access to a bed mesh visualizer. It's going to be right here. After we run a bed mesh, we're going to be able to see exactly the topography of our bed as visualized by Klipper. So you can see on the thermal history, it's showing me the peaks and valleys of how our temperature was hitting. So it was hitting 228, then it was coming down, and this is how a PID test works. It kind of, like a wave, it crashes and it spikes to better calibrate your temperature, keeping it at a set temperature. So Klipper allows us to see this history of thermal. So if we're getting a problem during a print, if like all of a sudden the layers are wrong or something doesn't look right, I can log onto my front end by using the IP address onto this front end, and I can look at the thermals and see like, oh wait, you know what? I'm getting a lot of noise in that temperature of my hot end. Maybe I should PID tune. Maybe it's not calibrated properly. That's why I'm getting bad layer adhesion, or that's why I'm seeing these really thick layer lines on the outside walls. Using all these tools that Klipper offers us, it's just going to help you get better prints overall. Going back to that configuration file, as you do certain calibrations like a bed mesh, they're going to save internally to Klipper, and they're going to be found at the bottom of this printer.cfg, right? This is the printer.cfg. If we scroll to the bottom, they're under this what's called save config line. And these are all calibrations that I've done that you will do that get saved to Klipper's memory, that get read right at the start of every time you restart Klipper. So I've ran PID tuning, as you can see. So my extruder, my hot end PID values are right here. My heated bed PID values are right here. Under that, this is the last bed mesh that I've saved. These are all the different points. You don't really know what they are. They're just probing points in the last mesh I created. And then the offset of my BL Touch, the Z offset that I have calibrated, it's stored right down there for me. So Klipper is going to store a lot of these settings for you. You'll never have to worry about every time you calibrate them. They just get saved to the bottom of this document. Below configuration, let me just venture to these two pages, system. So system is literally the host device. It's telling you what's going on with whatever is hosting Klipper. In our case, it's the Innovato Quadra running Debian Bullseye. It was Bullseye. Various utilization factors of the different functions that are going on. So if you have a Raspberry Pi Zero or a lower powered microcontroller, you may notice, a single board computer rather, you may notice that some of these levels are elevated, especially if you were plugging into a camera or using maybe an accelerometer to use input shaping. These levels might increase, and that's just simply because it's using a lot of bandwidth of those smaller boards. With the Quadra, this thing runs awesome. You rarely have any problems. I rarely see any spikes. All the usage is usually very low. And then you get the ultimate disk usage, how much more memory we have. 1.2 gigabytes, we're never going to use that in all our days. Below that is settings. You may think we're going to use settings a lot, and we really don't. Anytime we add something to the printer, a camera, give something like that, usually some new drop-down will import into this settings menu. So if we want to add a camera, we would go to this camera section, and then we would add a new camera in tandem with the configuration file that we would need to create. You don't really use this all that much. If you want to update, which you should often, come down to software updates right at the bottom, and we can update all the different tethers, all the different tendrils of Klipper, and they're all right here. And I believe if you click on the update, you will see what is new and why you're updating it. People are worried about updating Klipper because they think it's going to break something. Possible. I recommend updating as frequently as you can, just to try and steer away from that. If you want to change the name or something like this, under the general section of settings, right up here is the printer name. You can change it to wherever you want, and you can change the color. So right there is another name. This is a great way, obviously, to differentiate your printers if you have multiple web pages, and then you can change the color under the theme by just clicking the color and changing it. So I click select theme, and then I just click theme and change the color. You can also choose to change the icon. Again, tons of different icons down here to choose from, whichever you like. These are set themes for the community, whether it's a Rat Rig or a Voron, maybe a King Rune. Oh, I didn't know King Rune had one. Oh, that's pretty cool. Well, that's a new one. Of course, Corelli's got nothing. So just another way to enhance your experience or your time spent with Klipper. That's all. And it's just, if you have a bunch of 3D printers that are on Klipper, like I have, a large number of them, it's very easy to identify which one you're using by, creating a separate theme for it and a name. Very easy to do that. So our PID tuning is done. And in the console, it's telling me, it wants me to save the configuration, meaning we've done a calibration and Klipper wants to save it or commit it to its memory. A few ways to do it. We can click this button, Save Config. It's telling me right now, if I was to read this, it would tell me that. Or I can even use this top disk icon, which again says Save Config, right? So if I click it, it's telling me what parameters are new and what it wants to save and store and restart my firmware with. And that is just these new PID values. That's the calibration we just ran. I hit Save Config and restart. Those new values are saved, firmware is restarted, and they are now being used. So if I was to print after this, I'd be using these updated PID values, which should keep my hot end at a more level or temperature. Creating a bed mesh. If I wanted to do that, BL Touch is installed, the configuration file, printer.cfg has a BL Touch section. It's already set up for me. It's crazy, right? Because this comes out of the box with the BL Touch. If I wanted to create a bed mesh, I would first home my machine. I'd never seen all those styles before, to be honest, Cuddy. I thought there was like Rat Rig and Snake Oil and Voron and Klipper. That was it. There was a lot more than I saw. I never saw the King Rune one before. So we're going to create a bed mesh real quick just to show you what the visualizer looks like. And again, this is the front end of our 3D printer. This is now how we're interacting with our printer. No more touchscreen. Now you could use a Klipper screen if you want, which is basically this whole thing on a screen that's connected to your printer. But if you don't want to be next to your printer, you want to be upstairs eating dinner or something like that, you want to see what's going on, open up a web page, open up your phone, go to the IP address of your printer, of Klipper, and you'll be able to look in on it. You'll be able to watch it. Hooking up a camera to this is so simple. You really can't hook up a camera to Marlin. It doesn't allow you to do that. You can use things like Beagle Cam and stuff like that, other peripherals. Klipper just lets you hook up a webcam to this thing. You download Crow's Nest. You would do it the same way we install Klipper, and then we hook up a webcam. It's just so simple. It makes it easy. So I've homed my machine, and now I'm going to the Tune section. So we want to create a bed mesh, and I click Calibrate. Simple as that. This is going to go through the process, we can watch it here, of probing our bed, creating that bed mesh. And then after that, it's going to visualize it on that screen, show us exactly what our bed looks like. Klipper is just full of different tools, full of different ways to get our printer printing as efficiently as possible. Now, there are a host of different calibrations we're going to want to run when you first come on Klipper, and it would be the same thing as when you first got your printer with Marlin. Rotation distance used to be called E-steps with Marlin. It's how accurate our extruder is at pushing out X amount of filament. So we'll run 100 millimeters of filament through our extruder. We'll make sure that we get 100 when we ask for 100, and then we'll make some adjustments to what's called the rotation distance. It used to be called E-steps with Marlin. It's now called rotation distance. Where do you think that number is stored? In our printer.cfg. Under, what section do you think it's stored under? The extruder section. It has to do with the extruder, how much filament the extruder is extruding, so it will be found under that section, and it is right here called rotation distance. So we're not going to do it today, but you would, or if you even have your E-steps, let's say you've calibrated E-steps for your extruder previous to coming to Klipper, we can change that from E-steps to rotation distance. Then we would simply just put it into this document, save and restart, and now you have updated rotation distance. I've done rotation distance calibration on this already, came up with 7.44. That is one of the first calibrations you want to do. You're going to want to PID tune everything, of course, make a bed mesh, Is this music super loud? I can hear it now. I gotta change the song. It's crazy. What song is even playing? Oh, God. Okay. So we've created our bed mesh. I see the probe is stopped. Back to the tune menu we go. And here is our bed mesh. Yikes, this don't look that good. So this is the visualization of the topography of our bed. Our bed probe took different measurements, and this is what it projects our bed to look like. I mean, it don't look the best, but we have access to this. Now we can see, all right, listen, I see this corner right here, so this is my y-axis, and this is my x-axis. So if I was to look at the printer from standing in front of it, origin point right here, right, 0, 0, origin, top left, left to right is x, front to back is y. So now I'm standing in front of the printer, I see the back right corner is real low, and that front right left corner is real high. With a printer like this, there's not a lot we can do. There's no bed adjustment knobs, which is unfortunate, even though we could probably add them. We talked about that during the last live stream when we unboxed this. Not a ton we can do. Besides the visualizer here, it's showing us a very important number. This is probably more important than the visualization, the variance. And it's also right here. The variance is measured in millimeters, and it is 0.706. That is a variance, meaning a delta between the lowest measured point and the highest measured point. I would have to imagine the lowest point is right there, and the highest point is right here. That means the difference between those 2 points is 3/4 of a millimeter. And that's pretty high. That's really not good. If I was to try and do like a gigantic first layer square, I would think my bed probe can only compensate for so much. We really want this variance to be at 0.2 millimeters or below, ideally. I've printed with variances this high before. They will work. Just not ideal. You're going to get some areas of your first layer that probably don't stick or don't smush quite as well. But with a printer like this, there's not a whole lot we can do because it has a stable bed. It doesn't have adjustment knobs for us to make adjustments. Thus the name. But it does have some screws in the bed, and we could tighten things down to try and make it. That being said, this is what Klipper offers us. Klipper offers us a way to visualize that by using this probe. Now we can see, you know, on Marlin we used to have the screen with like just a grid of numbers and stuff, and it was like green or red. You can kind of see what's going on. This is a really nice visualization of that. One of the cool features of Klipper, and of course you can see it in different ways. You can visualize it in different ways. Everything kind of tells you what it's doing if you hover over it for the most part. After making that bed mesh, we could save this and we can keep reloading. It's just like in Marlin. Remember in Marlin, any 3D printer, we could probe before each print and use that, or we can probe outside of a print, which we just did, store it, and then use it before a print. And if we wanted to do that, we would use, again, the Save Config button. I see it right up top here. I click Save Config, and it tells me all the new data it wants to save. Pretty cool stuff. I would click Save and Config, and that was all the bed mesh points for the probe bed we just created. Firmware for me that it just did, and now it obviously restarts, and now I have that new bed mesh saved to my printer. Where is it saved? Printer.cfg. Anything that gets saved using the Save Config command gets saved under the Save Config section right at the bottom. So we did the PID extruder tune, that got saved there, and the latest bed mesh that we just calibrated got saved right there. That's Klipper. It's super, super simple. I probably went really quick on certain things, which I'm unfortunate, which I'm upset about. I really wish I could have gone slower. Getting to this point really was as quick as we did it. We copy and pasted a few lines onto our host device over SSH, that wireless communication, remember? We just copy and pasted a few lines to download Klipper onto it. Then we flashed Klipper using that onto our printer. Then we connected the two with a USB cord. We found out the address through SSH, that wireless communication. And then we added it to this printer configuration file that we found on the internet that someone provided for us. We're never going to create these ourselves. These are pin mappings in general of your main board. So this is information that's generally, I don't know why I want to say configured, housed here. This is all stuff from our main board. So if we look at the stepper X section, just for instance, we have a step pin, a direction pin, and an enable pin. Those are all pins on your main board. How do we find out the names of that? Well, in general, we don't. With Big Tree Tech stuff and certain companies, they will let you know what the pin names are for the different pins on your main board. Creality, other companies, they generally don't like to release that stuff. Sometimes Big Tree Tech's pretty good about putting the pins at the bottom of their main boards at the backside, so you know exactly what the pinout guide is. But that's what these letters signify, the different pins on your main board. You don't need to know that. You're never going to find these for yourself, trust me. Someone's going to have done this work for you, and we're just using it. So for the Stepper X axes to work using the stepper motor, the size of the axes, it's all housed under this section. These are all mainboard related things. They've been found out for us. Microsteps, that relates to your stepper motor. How many microsteps is that particular stepper motor using? Rotation distance, we talked about. That is the distance the axis moves, the distance it takes to rotate for the axis to move 1 millimeter. Don't need to know that. It's a standard number for the stepper motor you're using, and it's going to be filled out for you. End stop pin, same thing. It's the pin that the main board is using for your end stop. That's going to be gathered for you. And then these things down here, position end stop, position min, position max, those are things we can calculate ourselves. We can find out what the maximum volume we can print in is, and we can utilize that to our advantage. With Marlin printers, when we first got them, our Ender 3s were stuck at 220, 220. 220 millimeters in the X, 220 millimeters in the Y. That's all we could print within. But you really could print outside of those bounds. They just didn't want you to do that because they had clips on the bed. They didn't want you to snag those. But when we changed the clips and we got rid of them by adding a PEI bed or something like that, well, now we opened up more printing surface. Klipper is going to allow us to find out exactly how far we can go in every direction, and then we can print. We can use those extra bounds. We do that by adding a position minimum, how far we can go in the minimum, and a position maximum, how far our axis can go in the maximum. It's pretty cool. Klipper allows us to make those edits directly here in this configuration file, save it, restart it, and then those different changes take effect. Any questions so far? I feel like B-Cuddy is doing all the question and answer work in the comments, and I appreciate it. I haven't looked at these comments whatsoever because I'm just going about Klipper. Any questions? Where we're at? It's confusing. It's not confusing. The way can be describing it may be confusing, and I apologize. I like to be a little more streamlined with these kind of things, but there's not a lot going on as far as what we have to do thinking-wise. It's just copying, pasting, moving things around, getting Klipper onto the host device, our Quadra, getting Klipper onto our 3D printer, marrying the two with a USB cable, finding out the address. Now we have a 3D printer that is capable of running Klipper. That's it. Like, we have a Klipperized printer right now. We can start uploading files onto it, G-code files, and printing with it. Simple as that. So if I was to go to Orca Slicer, where's my Orca Slicer? Here's Orca Slicer. It's a newer slicer. I've been using this a lot lately. Let's get rid of this Gladiator helmet, 300 helmet rather. Drop down to a new printer. I already have one in here. Not a lot you need to do when you introduce a Marlin-based printer to Klipper in your slicer. The real big thing is, for Orca at least, there's a printer section, a section for your filament, and a section for the profile that you want to print with. The printer section is really what you want to concentrate on with Klipper, because there's going to be an option, if I click the preset, for the flavor of G-code. One is Klipper and one is Marlin. It's obviously RepRap. Marlin 2, I have no clue what that is. Did they update it recently, maybe, in the beginning of 2022? So you'll click Klipper. I don't even know if Cura still uses, if Cura has a Klipper section, but Orca Slicer does, Prusa Slicer does, some of those Super Slicer, which is, of course, a fork of Prusa, they all have the option of Klipper. And what that does is takes out some of the Marlin commands and introduces Klipper commands. Klipper uses G-code just like Marlin does, but Marlin has certain MG codes that Klipper doesn't use. The biggest one that you probably know is M600 filament change. So the word M600 is like a macro to Klipper. To Marlin, it means filament change. M600 gets read by a Marlin-based 3D printer, and a filament change operation begins. Klipper's got no clue what M600 means. It reads, it's like, all right, M60, I have no clue. It doesn't use certain M codes. So what you would do with Klipper is you would just create a macro in its stead. So instead of M600, you would create something that says change filament. And it would, let's do it right now. This macro would simply change your filament like M600 would. To be honest, what most people do is just name a macro M600, and I'll show you why. Let's say I add a cube, and I slice it, and at about, I don't know, the halfway point, I want to change colors. I would add Marlin, I would add a filament change. I would go to this, for Orca Slicer, this slider that I slid it down to. I would right-click it, and I can add a pause. I can add custom G-code, or I can jump to layer. So if I was to add custom G-code, I would write M600 if this was Marlin, and then at that point, you could see it, I have an M600 triggering. It would get to that point in the G-code, M600 will happen, Marlin would know it's a filament change, and your filament change would take place. Klipper's got no clue what that is, so we have a few options. You could make a macro in Klipper named M600. So now all the slicers that only use Marlin, that are going to use M600 for filament changes, Klipper can identify that and use its own filament change. So it would look like this. So I have a separate file for all my macros. Here is one of them. Here is one of them. G-code macro. This starts by identifying itself as a G-code. We know it's a macro. And then the name, space, and then the name, M600. I could name this whatever I want. It's up to me. It's a macro. I can name this filament change. And then every time Klipper was given the code filament change, written like this, it would perform everything underneath it right here. We don't do that. I make my G-code macro for filament change M600 simply because most slicers use M600 as a filament change, so it's just very simple to keep those two things together. That's really the only reason most people use the M600 documentation naming convention for the filament change in Klipper, if that makes sense. It's just to keep it consistent for everyone. Underneath that, underneath the title of the macro, we have the word G-code. It's telling us that this is the G-code that this macro is going to perform. You'll notice there are several different colors going on here. The top colors right here, these are variables that are being set for your macro. So for instance, let's say I tell you to boil some pasta, right? Boil some pasta, please. Well, you don't know what temperature I want the water to start boiling at or start at. That's what these little parameters do. This is saying, all right, if you don't tell me what temperature to start the water at, this is what you started at. It always has a backup. So if you don't input certain parameters, there's always parameters input just to make sure you don't make a mistake. And that's what these light green lines are doing. It's always giving us a default for stuff that has to be plugged in further down in the macro. It's just to save yourself. Below that is all the different lines of this filament change macro. These are G-code lines. I'm not going to go through them one by one, but I'll briefly go through it. Save G-code state is going to save where we were at. This way we can stop the print, or when we stop the print to change filament, we need to know all the different conditions that were happening right then. How much extrusion was happening, exactly where we were relative to the model, stuff like that gets saved, then it gets paused, the hotting gets moved away. These are all the different movement commands. It's going to take filament, it's going to eject some filament forward, then it's going to remove the filament. It's going to give you an idle timeout. It's going to sit there while you replace the filament, and then you're going to be able to resume after that. And the resume is restore G-code state. It lets the printer know where it used to be so it can pick up right where it left off. That's what that macro does. And you'll see, you would never use this outside of a print. Obviously, it's a filament change macro, but because it's a macro, it's going to be under our macro section right here. And it has parameters. Those light green sections were parameters that we could change if we want to. So if we called it, if we use that macro, we could add different parameters to it where we want it to park. This is parking at X50, Y0, Z10. You could change that if you want to. A lot of them can be left default, but those are there just to provide a safety net for us, so there is some default parking. I definitely have gotten too far. Yeah, I've definitely gone too far at this point. Clear for everyone. The more you see it, the easier it becomes, I guarantee. But it puts our 3D printer in a very easy to understand way, or a very easy to manipulate way by using this webpage. Not for everyone. Definitely not for everyone. But if you do want to explore it, I recommend it. Come to the Discord, come to the website, watch us on YouTube. trying to help Klipper get there slowly but surely. Next few videos, I think I'm going to do like an Octo Everywhere video. I have to get that one out. It's a really good feature that Klipper is utilizing, or that also utilizes Marlin, I believe, if you have a camera. And you could just access your printer from anywhere. So if I started the printer and if I started the print and I went to work, I could just check in on it, make sure nothing's going wrong. If it does go wrong, I could stop it. It also uses AI failure detection, so when you're not watching your 3D print, like AI is watching it for you, making sure nothing's going wrong. It's actually pretty accurate. I've had it save me a few times. Then after that, I need to do max acceleration, max speeds. People have been asking about that one for a long time. It's a very important one. It's just, that's an onion of a video, because our maximum speeds and our maximum accelerations are throttled by certain things like flow rate and cooling. So max speeds and max accelerations are physical printer speeds, are mechanical speeds. What is our max mechanical speed? What is our max mechanical acceleration? Then we have different speeds. What is our max printing speed? Those are two different things. So how fast can our 3D printer move and how fast can our 3D printer print are kind of two different things. And in that video, I kind of want to go over all that stuff very individually, but you know, break it down as best I can. Pressure advance. Well, I do have a pressure advance video. I can go over pressure advance. So what I've been using lately is Orca Slicer. I showed it to you earlier, and for the reason it's very quick. I like the UI, I like the user interface, and it has some built-in calibrations. Maximum volumetric flow rate is one of them, and then pressure advance is another. Oh, I should probably show you what's going on. So here's Orca. Let's get a load of different printers because I like this KLP one behind me. So calibration right at the top. Select pressure advance. Then a drop down comes on. What are you using? How do you want to do it? Different methods to do pressure advance. They've added Ellis's pressure advance pattern to this. I use the line test. I don't even know what the pressure advance tower is. I would suggest not using it, I guess. Either the pattern test or the PA line test. Then you have to decide, do you have a direct drive extruder or a Bowden extruder? Direct drive means the extruder and the hot end are sitting right on top of each other. For instance, the Ender we use today has that. Bowden style system is like the old school Ender 3 Pros with the Voxel Aquila. The extruder and the hot end are separate, and they're connected by a tube called a Bowden tube. That is a Bowden setup. Direct drive is right on top, and they are different for the means of this. So today our Ender 3 V3 SC direct extruder, DDE, that's what we're going to choose. That depends on what the steps are. Oh, they actually fill it out for us. That's even good. So once you choose your extruder type, the start and end values are populated for you. You hit OK. When you slice this thing that says PA test, you will see what it's actually going to look like. And it looks like this. So how this test works is every line is going to be a different value of pressure advance, and to the right you'll see it denotes what every other line is. So the first line has no pressure advance at all. It's going to start. It's going to start by printing a very slow section, which is denoted by this blue line, and then it speeds up, and then it slows down again. And what this is doing is it's trying to see how much pressure is built up in your nozzle and how much extrusion or how much filament is being placed while it's going at whatever speed you have set it to in your printer settings. So right here, I have a normal printer setting, so my top speed and the first layer is 152. It starts at 20, it goes up to 152. You can see it's color-coded, and it goes back down to 20. So it's going to be slow printing, acceleration, and then slow printing. And this is going to see how much filament you are not getting in your nozzle, or how it's not depositing correctly along the line. It starts with no pressure advance at all, so it's just going to go as your printer would normally operate. And then as each line continues, it's going to add pressure advance, 0.02, 0.04, 0.06, so on and so forth. What this is doing is it's basically giving you, it's mimicking what the correct pressure in your nozzle should be. So if you are going so fast that you're seeing empty spots at the beginning of your line, pressure advance is going to give you a little extra filament. It's going to it's going to push extra filament into your nozzle at the beginning of your lines to make up for that speed, that takeoff, that not enough pressure has built up. And at the end of your line, it's possible too much pressure has built up. And as it slows down, all that extra pressure is going to push out more filament, and you'll get blobbing at the end of your line. So what pressure advance does is at the beginning of those lines, it advances the filament to make up for, if you're going too fast, you're not putting down enough filament, it advances filament for you. And now you get a nice even line. And at the end, when there would be too much pressure in your nozzle, an extra filament will come out and blob, well, it's going to retract it a little bit. And that's what pressure advance is. That's what those settings are, 0.04. That's the millimeter, 0.04 millimeters of advancement and retraction of filament that this is going to offer us. And all that's attempting to do is get a steady bead of filament for any given line based on your speeds and your accelerations. If we were going very slow, if you were sprinting at 20 millimeters per second with 1,000 millimeters squared acceleration, you're not taking off too fast, you know, your extrusion of filament is going to be very consistent, very constant. With Klipper, we are taking off pretty quick, we're going pretty fast, and then we're slowing down very fast as well because we need to stop and change direction. So what pressure advance is aiming to do is it wants you to still get that consistent bead of filament, however that line is. And pressure advance is going to advance filament at the beginning of your lines. So as you take off, there's enough filament getting deposited. And at the end of those lines, it's going to retract filament. What this test is showing us is let me get to the end of it. And here you'll see all the pressure advance values to the right. It's simulating whatever those pressure advances would be on the given line that it's showing. So at this line right here, 0.04 pressure advance, it's going to simulate what that would be for this line. And on this test, we're looking for the most consistent line because that means it's advancing the right amount of filament and then it's retracting the right amount of filament at the end. Now, you're never really going to get a perfect pressure advance number. It's always going to be pretty good, but not the best. It's just how it works. Every roll of filament might be different. Colors of the same filament might be different. In general, though, what I like to do, I mean, you know, time is of the essence. How much time do you have? If you don't have a lot of time, I use the same pressure advance for the most part on all my PLA rolls. For instance, if I'm using King Rune, if I'm using 3D Max, something like that, I have one pressure advance value for PLA that I've calibrated, and I use it for all of them. For every material type, I use a different one. PETG, I've calibrated that. That has a different pressure advance. ABS, I've calibrated that. That has a different pressure advance. Now, generally how I tell people to store it is directly within Klipper. So I'm back to my Klipper front end. Where do you think we're storing it? Printer.cfg, right? I go to configuration, I find my printer.cfg. Now this is something that's related to the hot end, to the extruder, so it would be under that section. So I find the extruder, and then is it in the extruder? Am I losing my mind? Do I not have pressure advance? All right, we don't have pressure advance calibrated for this 3D. Oh, I know why. So in general, I have people, when they first start out, input their pressure advance under the extruder. So let's say we calibrated this, and I found the number to be 0.04. That would be the pressure advance we would use on every print. I would save and restart, and every print I used would use that pressure advance. Newer slicers, a lot of newer users don't want to, use it in printer.cfg because let's say that's the pressure advance for PLA, and for ABS my pressure advance is 0.23. Well, every time I change from ABS to PLA, I got to come in here, I got to change this, I got to save and restart. An easier way would be to just put it directly in your slicer. Some slicers offer it, some slicers don't. So this is King Rune ASA, it's just like ABS, and if I found this pressure advance to be 0.023 for all my ASA prints, I would go into my filament profile and I would enable pressure advance, and then I would add it right here. So now whenever I slice an ASA print, it's going to input the correct pressure advance to me and send it to Klipper. So this way I kind of take that information out of my printer.cfg and I add it to my slicer. This way, when I change, so here we go. When I slice ASA, it's going to have a pressure advance of 0.23. Now, all right, I don't want to print any more ABS. Let me go back to PLA. If I go into PLA, I set my pressure advance to 0.05. I slice that, it'll change it to 0.05 for me. I don't have to go into my printer.cfg and constantly make those changes. So that's why I love doing it from the slicer. But when I first explain it to people and I first tell them how to use it, I tell them to just house it in their printer.cfg because it's just easier. And sometimes when you change to a new filament, let's say I didn't save this, and I changed to ASA, if I was only saving pressure advance in my slicer and I go back to PLA, I forgot to save it, there's no pressure advance. I tell people to store it in their printer.cfg at first, just to make sure they're doing it right and it's constantly going to be there. You're always going to have pressure advance. Ultimately though, when you feel comfortable that you know what you're doing and you know when to look for pressure advance and how to calibrate it, I would recommend storing your pressure advance values in the individual filament sections if your slicer allows it. Orca slicer allows it. I know Prusa slicer allows it. So that's how I would recommend to do it. I would recommend using this lines test, but you can also use the pattern test, which is Ellis's pattern, I have to imagine. Yep, that's Ellis's pattern. This is the same idea. It's just adding a turn for acceleration purposes. So it's going to be a fast line the entire way around with a 90-degree curve. So you want to look for whichever curve is the sharpest and has the least amount of blobbing on each side. I am so bad at identifying the best line on this test. I just don't use it. But it's probably very, very good. This is probably the most accurate test. Better than the lines test. But again, it's just, for whatever reason, I can't discern which line is best, so I don't use it. So yet another way to change, to tune pressure advance. And then of course, once you get your values, save it to your filament profile or save it into your printer.cfg. Add a comment next to it so you know which material has which numbers if it's in your CFG. And that's it, you're good to go. That's pressure advance. And if you see rippling on the outside of your models, tearing, tattering, it's either pressure advance, which is likely what it's going to be, or your flow is too high. You're printing too fast for your flow. Flow is another thing we're going to talk about at some point with Klipper. It's how we determine our speeds, our max speeds. We print. After you find your mechanical max speeds and mechanical max accelerations, you won't be printing at those. You're going to be throttled, and you're throttled by this maximum flow rate. The way we determine it, a few different ways. One of them is by a printed model, where we're going to print in different flow rates. This is determining, flow rate is determining how much melted plastic we can push out of our nozzle. That's it, at what speed. So this is determining different flow rates for our printer. We're going to print this during that video. It's going to tell us what our max volumetric flow rate is. We take our mechanical speeds, we combine it with our max volumetric flow rate, and that will give us an idea of what our maximum printing speeds are. Of course, there is the real world issues of, can you cool this print fast enough? That's another issue. We'll go over that another time. If your direct drive requires more than 0.1 pressure advance, there's likely something wrong with the extruder, the extrusion, maybe your rotation distance is off. Anything over 0.01 for direct drive is very high. That means you're over a millimeter, over a tenth of a millimeter, obviously. You're either advancing or you're retracting way too much. Same goes for Bowden. Bowden is moved the decimal point over 1. If your pressure advance for Bowden is over 1.0, that's too high. There's likely something wrong there. What it is, hard to say, but I would try and track it down. Anything over 0.1 for a direct drive is too much. Armor 3D, what up? I don't know when that comment came in. I'm so sorry. It's been crazy. All right, we've gone on too long. We did an intro to Klipper. It was good. It wasn't great. It was good. It wasn't great. It was medium. It wasn't good. But we did it. I hope there was something to glean from this, even though I feel like there wasn't a lot of information. I feel like I wasn't prepared enough, and I apologize. The long and short of it is, Klipper is pretty simple to get on your 3D printer. I did it in about 7 minutes, in real time. And then we have access to the front end, we have access to different calibrations, and we go from there. I'm going to do a longer series. This is only the first one. I want to take feedback on this and other areas of Klipper and see what people have trouble with, and then try and kind of hone in on those. I want to kind of go into the printer.cfg, the templating of our configuration files, and help people with that. I know this wasn't the most informative. Oh, my phone died, so I apologize. But it's a jumping off point. It's a diving board to get there. So I appreciate everyone that stopped by. We're going to continue this series maybe next week or the week after that. I have an unboxing coming up in the early new year, so we'll be doing that on live on stream. And we'll just do more Klipper stuff. We'll do hands-on Klipper calibrations if you want next week, either pressure advance or even input shaping. I can show you some of the configuration files I use. If you've watched this, if you're still confused, if I confused you more, I apologize. Leave a comment or email me or join the Discord. Let me know what you want to see or how I can rectify that. And that's what we'll focus on for the next live stream. I just want to make sure, I want to try and onboard people to Klipper as best I can. I wanted to make this live stream a video. I can never find the time to do it because I'm trying to make videos, Klipper calibration videos for people who have been onboarded already, and I know they're dying for them. So I want to try and make these. I think live streams are a better idea for this type of concept. I don't know that I was ready for it. I tried to do my planning and my blueprint, my homework as much as I could, but this week has been crazy for me. I got home like 4 minutes before I went on stream. So I wish I could do it better. I think I'm going to do it better again, or I'm going to continue this and improve it. I want to dive even deeper into Klipper. So like some of the stuff that people who use Klipper now don't know, G-code stuff, slicer stuff, more calibration stuff, some kind of cool things we can do using WinSCP or SSH if we have issues with Klipper. I want to get into that as well. That's definitely a different video. I want to just get a little bit of walking before we run videos, and this is definitely part of that. So if you stay this long, I appreciate it. If you have any feedback, please leave it. Let me know. I can't see anyone's comments right now because I use my phone to see the comments because Stream Elements just doesn't want to show me it. So, and my phone's dead. So if you're leaving a comment right now, I apologize, but thank you so much for stopping by. We got videos coming up. Octo Everywhere I mentioned. That's probably our next video. Max Acceleration. We have an unboxing, live streams. Trying to live stream again next week. This time, this place. I have my dad's birthday though, so we're going to see. But thank you all for joining me. I appreciate it. If you left a comment, if you saw it, peace out, love it. Thank you so much. Leave me some feedback. Gotta know what I did wrong, because I definitely think I could streamline this better. I think I could teach this better. So it's a learning experience for everyone, including myself. So thank you so much for joining me. Have a great night.